Okay, in the next two exercises, we're looking at velocity and acceleration now, not in terms of t. Okay, we're looking at, so you know how normally with 2 unit, we know that v is dx dt. This is with 2 unit. And a is dv dt with 2 unit, or d squared x by dt squared. That's what we've done in 2 unit so far. So in 2 unit, we look at velocity with respect to t and acceleration with respect to t as well. All right. But in extension 1, so we're now looking at extension 1, we'll be looking at velocity and acceleration, not in terms of, I know this is in velocity is dx dt, but you'll get x equals something t, like you'll get x equals something t. X is always in terms of t for this. So in 2 unit, x will be in terms of t. And we find v is dx dt, a is dv dt. But with extension 1, in exercises 6.8 and 6.9, we don't look at velocity and acceleration in terms of t. We look at velocity and acceleration in terms of x, not in terms of t. So that's what's happening for the next 2 lessons, velocity and acceleration in terms of x. It's also called, so this exercise 6.8 and 6.9, it's also called rectilinear motion. Don't ask me why. Okay, so you'll see it described as that, velocity and acceleration in terms of x, or rectilinear motion. Whenever you see that, that is extension 1. 2 unit will be velocity and acceleration in terms of t. So here we go. So exercise 6.8 again, velocity as a function of displacement. Now in these questions, so velocity is a function of displacement, exercise 6.8. Just a little rule. If the velocity is given as a function, so this is extension 1. This is extension 1. If the velocity is given as a function of displacement, not time, this is what we do. Step 1. Take the reciprocal of the velocity to give dt dx. I'll show you what that means in a minute. Now when you're doing dt dx, you're now as a function of x. And step 2, then you integrate with respect to x. Now, this is what we're going to do. So if velocity is given as a function of displacement, not time, you take the reciprocal of velocity. Now we know that velocity is dx dt, so we take the reciprocal, which is dt dx, the flip, and then you can actually integrate that with respect to x to end up with what t is, all right? Sorry, to end up with what b is. So you'll take the reciprocal and then you'll integrate with respect to x. Actually, that will give you t, not v. So we'll just do an example. Do you want me to start with an example? I think it's just best to do examples with this. Example. The example that we're going to look at is question 3, which is over here. Okay? So the velocity of a particle, I'll just make that a little bit bigger. So, and I'll just move it. Is question 3 over there. It says the velocity of a particle is given by v equals 1 over 15 x squared meters per second. See, now that is velocity in terms of x. Can you see the x? It's not velocity equals something t. It's something, velocity is in terms of x there. So we've got that velocity equals 1 over 15 x squared meters per second. Now the rule is, if velocity is given in terms of, so if velocity is given as a function of displacement, in other words, in terms of x, not time, what do? So I'm going to write this as dx dt. We know that velocity is always dx dt, whether it be the 2-unit course or the 3-unit course. Velocity is dx dt, but the problem is I can't integrate or anything like that until I, see, if I want to integrate here, it'd have to be in terms of t. All right, so I can't do that. So what I do, I take the reciprocal. So dt dx would be what? 15x squared. So therefore t is the integral of 15x squared dx. You know, if you've got dy dx, for example, was that, you get y is the integral of that dx. You're integrating with respect to x. You can do it because this is now dt dx. When you've got dt dx, this has to be in terms of x, not t. Okay, this is like dy dx is that, so y would be the integral of that with respect to x, same thing. So t equals the integral of 15x squared dx, which happens to be 15x cubed on 3 plus c. Okay, so therefore t is 5x cubed plus c. Now, what do we have? It says find the displacement. So it also says, and the particle is initially at the origin. What does that mean? When t equals 0, x is 0, so we get 0 equals 0 plus c, that gives us c is 0. So we get t equals 5x cubed. And the question is, find the displacement after 4 seconds. When t equals 4, x equals question mark. Oh yes, thank you. 4, it says find its displacement after 4 seconds. When t is 4, we're finding x. X is 4/5, which is 0.8, isn't it? 4/5 is x cubed. Therefore, x is the cubed root of 4/5. It's the cubed root of 0.8, which is what? 0.93 x meters. X is meters, it's distance, displacement, meters. Cubed root of 4/5. Okay, we'll just look at one more. Let's choose a question. So the velocity of a particle is given by that, dx dt equals e to the negative 2x meters per second. If the particle is initially at the origin, which means when t equals 0, x is 0, they want you to find the time when the displacement will be 1.5 meters. So find t when x is 1.5. So what are you going to start with? dx dt is e to the minus 2x. Can you rewrite that, please? Rewrite it as a fraction. What does negative power mean? 1 on e to the 2x. Now it's easy. So if you don't do that, so now what's the next step? This is velocity in terms of x. We don't want velocity in terms of x. We flip it. So dt dx is e to the 2x. Therefore, t is the integral of e to the 2x dx.
Why did you get rid of the negative 2?
No, because e to the negative 2 on x, you know, e to the negative 3 means 1 on e cubed.
Oh, yeah, sorry.
You know, negative power means 1 on.
Yeah.
Okay? It just makes it easier to flip. Otherwise, how are you going to do the reciprocal of that? Are we good? And what do you do when you integrate that? Is it the 1 on 2? 1 on 2, e to the 2x plus c. Then you'll substitute. T is 0, x is 0. Keep going. And we'll get that 0 is a half e to the 0 plus c. Well, e to the 0 is 1, so what does c equal? So therefore, good, t is a half e to the 2x minus a half. So you can answer the questions now. Find the time when the displacement will be 1.5. And then you can do part B as well. Find the displacement after 5 seconds. We'll get to that. So the first part, exact time when displacement's 1.5. Sub x is 1.5 to find t. So we've got t is a half e to the 2 times 1.5 minus, I'm going to write a half as 0.5. So it's a half e cubed minus a half exact time. So actually keep that as a half if they want exact. And how do you write that nicely? So it's a half e cubed minus a half. They want exact values, so I'm not writing 0.5 anymore. How do I write that as a common denominator? Yeah, it's just e cubed minus 1 on 2. So that's the exact time when the particle, when its displacement's 1.5 seconds. So write minus a half. And part B is to find x when t equals 5. And they want that one to 1 decimal place. You've got your formula, t equals a half e to the 2x minus a half. You can just put them both over. You can just put e to the 2x minus 1 on 2 if you want. So that's really e to the 2x minus 1 on 2. So find x when t is 5. So I'm putting the 5 in. Best to write the common denominator, don't you think? E to the 2x minus 1 on 2. Just makes it easier. So what do you get? 10 plus 1. 5 times 2 is 10 plus 1 is e to the 2x. Are we good with that? 5 times 2 is 10 plus 1. Therefore, 11 is e to the 2x. Take t lobs. Taking logs of both sides, you get what? ln 11 is 2x. Therefore, x is ln 11 on 2. 1.2 meters. I'll just pause. Yeah? All right. I do want to try and do the next exercise too, because it's acceleration in terms of x, if we can. And that way, you've just got to work hard on the weekend, girls. Question 11 is the next one we want to do. The velocity of the particle is given by this. So velocity, which is dx dt, is given by 1 over 4 cos 2x centimeters per second. We know initially, when time is 0, particles at the origin, x is 0. Find the exact time when the displacement's pi on 6. That should be okay. Find the total time of the motion is the one that's is a bit different. And we'll have. So part A is saying to find t when x is pi on 6. So find the time, exact time by the way, when displacement's pi on 6. Okay? So taking reciprocal, dt dx is what? Does the 4 go to the numerator? Yes. You swap, flip. 4 cos 2x, not 1 on 4 cos 2x, it's 4 cos 2x. It's the reciprocal of that. Therefore, t is the integral of 4 cos 2x dx. You okay, girls? Swap the numerator and the denominator. Full swap. Which is, when you integrate cos, when you does the sign change or stay the same? Yep, so we get 4, what do we do now? Times. Yeah, what's the rule? 1 over 2 sine 2x plus c. So we end up with 2 sine 2x because it's 4 is the constant. When you integrate cos 2x, you get 1 on 2 sine 2x. You do have your formula sheet. No reason to get this wrong. So we're going to substitute. No, we're just finding t when x is pi on 6. So 4 times a half is 2 sine 2 pi on 6. Oh, wait a sec. What am I doing? Thank you. I just noticed. When t is 0, x is 0. So we get 0 is 4 times a half sine 0. What's sine 0? You get c is 0. Because that's 0. Just write it. At least just write c. If you don't do plus c and make the statement that c is 0, they're going to think that you don't know to add c and work it out.
Can you just write t equals 0, x equals 0?
C is 0. Yeah, that's okay. As long as you're making some statement. As long as you're showing this and showing that you're physically working it out and that you acknowledge that you need to work it out. All right? But if you ignore it, if you don't put the plus c and show that you've done it, you're going to lose a mark. Okay? So therefore, t equals 2 sine 2x. So now we've got when x is pi on 6, t is 2 sine 2 pi on 6, which is 2 sine 2 pi on 6, which is 2 sine pi on 3, sine of 60, which is 2 times root 3 over 2, which is root 3. It's exact. Seconds. Anyone know what root 3 equals approximately? Well, it's less than 2. 1.73 something. Okay, good. B. Find the total time of motion.
So does that mean you have to see when velocity is c? I mean 0?
Let's just write what the formula is. Find the total time of motion. T equals 2 sine, here's the formula, 2x. Oh, I know what it means. I think it's got to do with the period, girls. Let's sketch it. Let's sketch. How else would you do this? You don't know what to substitute to find the total time of motion. So I'm going to do a sketch. What does it look like? Sine curve, amplitude what? And you can just draw it, and then you're going to decide this is not 2 pi, but period, yeah, period is 2 pi over 2, because it's got to do with that 2, which is pi seconds. So the time of motion is what? What do you think? Well, they're not going to ask you. It's the time of motion is the time for a full cycle. It's pi seconds. Because how do you know? Is it going to do 1, 2, 3? We don't know. The total time of motion will be 1 period. It'll be pi seconds. So the total time of motion, this is t. No, this is x. Sorry, I'm wrong. That's t. I better draw it properly. I'm not finished, sorry. The period is pi. This is the graph. Well, look. But, no, guys, isn't this t up here? Oh, got it. Yes, I know it. Sorry, guys. This is x displacement. This is t time. This is the correct graph because you can think of it as, I suppose, y equals 2 sine 2x. You would draw it like this. The y would be there, the x would be there. Amplitude 2, period is pi, not pi seconds. The period is just pi for this graph, but the time's actually up there. So the period's just pi to draw it. I'm not going to give it units. All right? Now, that period, yeah, whatever. Yes. Good. Period is pi centimetres. Now, total time of motion. Let's just look at part A's result, the exact time when displacement's pi on 6. At the moment, displacement's pi. Here, displacement's pi on 2. Here, displacement's pi on 4. We good with that? Pi on 6 is roughly here, which is root 3. Makes sense. Root 3 is 1.7. That looks good. So this is root 3 here, pi on 6 down there. So that's what that part A question was asking, and that fits in well with our graph. Are we okay with that? Now, I've just drawn the curve for t versus x, time versus displacement. If I go back to the original velocity of the particle, I'm going to draw that curve. So, actually, I'm not going to draw it all. I'm going to draw, you know how velocity is 1 over 4 cos 2x, okay? I'm just going to draw 4 cos 2x first. That would look like this, wouldn't it? That's 4 cos 2x. 4, negative 4, period is what? Pi. That's what 4 cos 2x looks like. In another colour, I'm going to draw 1 over, so in another colour, I'm going to draw v equals 1 over 4 cos 2x. Now that's just, what's the reciprocal of cos? Sec. It's just the sec curve. So 1 over, so looking at each point, 1 over, when x is 0, this is 1, so 1 on 1 is 1. But when x is 90 degrees, oh, you know what, oh no, it's not 90. Well, 1 over that 0 there, you don't have to worry about what you're substituting. But 1 over 1 is 1. 1 over 0 is undefined. Wait a sec. Because I'm drawing the velocity curve. And the total time of motion at this stage here, there's a break in the curve. See, total time of motion to me sounds like, well, it is the total time. When did the particle start and when did it stop? It's got to stop here because there's a break, there's an asymptote in the curve. So that's when the motion finishes. Okay, because there's a break. I've actually drawn the velocity curve, and velocity is undefined where my vertical asymptote is there. See, you know, if we were drawing a curve like this, you'd say to yourself, well, how long does it go on for? How many reps? We don't know. There's obviously got to be a break in the motion somewhere to get the total time of motion. So which is why we've drawn the velocity curve, to see if there's anything in that that gives us an idea of what's happening. So that's 4 cos 2x. Velocity is 1 over 4 cos 2x is this curve. So therefore there is a break, a stop. The motion stops. I'm not saying velocity is 0 at that point, because it's not, but there's no more velocity. It's undefined. So when t is a quarter, and you can see it's sort of approaching that. It's like it's as t approaches. We really want to be doing as t approaches, as x approaches pi on 4, what's happening to the velocity. So we know at x equals pi on 4 that there is a stop. Well, the particle, I'm not saying it's 0, but there's a stop in the motion. There's no more motion. I can say that. Velocity is not defined. Are we okay with that? At x equals pi on 4, velocity, not saying the particle stops, but there's no more motion anymore. Velocity is undefined. So if I put pi on 4 back into here, so now I'm going to sub x is pi on 4 into t equals to 2 sine 2x. I'm going to get 2 sine 2 pi on 4. So from there, I'm coming over here. Sub x equals pi on 4 into t equals 2 sine 2x. So we get 2 sine pi on 2. What's sine pi on 2? 1. So it's 2 times 1, which is 2 seconds. Now, that's looking at it that way. How could you, the other thing you could do is, if you do draw this graph, I actually don't have to do the substitution. I can read from this graph that when x is pi on 4, t is 2. You can just read it from the graph. Can you see that? So instead of doing the substitution, I can look at x is pi on 4 in my t versus x graph, and I can see that when x is pi on 4, t is 2, just by looking at the graph as well. Look, this makes that very, so total time of motion is not, do I do 1 period or 2 periods? There's obviously something that happens that makes the motion stop. And by drawing the velocity curve, it's very clear that it happens here at t, that at x is pi on 4, that we have a break in the motion. Well, the velocity curve doesn't exist anymore. There's an asymptote. So that's when you look at x is pi on 4 back here and get the total time. You get the time when x is pi on 4, it's 2 seconds. Now, I'm happy with that explanation. I think, you know, just saying it's the maximum there, that's just a hit or miss, a guess. This actually is explained as to why it happens. All right, your homework will be this exercise. And I'll just definitely question 12, 10. Why don't you just do them except for question 1? Start from 4. So we'll do question, well, 4 looks easy. Start from 5. No, start from 6. Yeah, just do 6 till the end. 6 till the end, and I'm sending you the Cambridge stuff for this too. So 6 till the end plus whatever Cambridge I give you on this. Got it? Question 6 till the end. Obviously, you're not doing question 11 plus the Cambridge stuff.